Check out the Von Karman clouds near Guadalupe Island. Some swirling clouds here. Check this out. So that's Guadalupe Island there, and you've got this wind flowing past it, creating these vortices on the leeward side of the island. Great example there of some weather pornography for you. You can find this on AccuWeather.com's news area. Some stunning Von Karman clouds captured by satellite. Let's take a look at the jet streams. First, the surface winds. Here's what's going on in terms of surface winds in the western portion of Earth. Here are the jet streams, and completely chaotic jet streams here over most of the U.S. And it's creating some turbulent weather and some massive flooding risks. We'll get to it. First, the jet streams of the eastern world. There are those. And here are the surface winds. And this tropical cyclone has made landfall here on India now, actually, so we can expect that to weaken, fortunately, as some death and destruction have been resulting from that. Next, looking at lightning maps. I like to use lightningmaps.org when I hear thunder. And it looks like we've got some terrestrial lightning here. Large portions of Texas. Hey, Lubbock, get outside and look to your southeast, your south-southeast. Anyway, that's some of the most intense lightning on Earth right now. Also down here near Corpus Christi. Some thunder looks like it's rolling in there as well. Anyway, there's your global lightning map. Here is your visual analysis of it. Very strong lightning here over the Oklahoma Panhandle and much of Texas. Also Louisiana seeing some strong storms there and some heavy lightning. Let's talk about climate. Greenland is melting, folks. Greenland is melting. Now, it's summertime in the northern hemisphere. And in the summertime, the snow that fell in the wintertime melts. That's what happens. Now, Greenland, around the solstice, a large portion of Greenland is lit all day long. And it gets very hot in Greenland. And when you have a lot of snow, guess what happens? You have a lot of melting. So here's a lovely alarmist article on phys.org in the Earth section. Part of Greenland ice sheet may be close to tipping point. And we cover this each summer as we see ridiculous, nonsensical articles trying to cultivate fear and suggest that, oh noes, Greenland is going to melt and it's going to cause global sea level to rise by 7 meters. If you're scared and spooked about this, if you're frightened, leave us a comment and let us know. Let's take a look at some data. So, here is the snow mass, and it's funny because they actually talk about snow mass balance. Let me read the paragraph here. An ice sheet can only maintain its size if the loss of mass from melting and calving glaciers is replaced by snow falling onto its surface. The warming of the Arctic disturbs this mass balance because the snow at the surface often melts away in the warmer summers. Well, let's see how much it's been snowing in order to melt. Oh, look, it's 2 standard deviations above normal snow mass balance for the past 4 consecutive winters. So here's the past winter, and you can see how outside the 30-year average that is. The blue shaded area would be the 30-year 1 standard deviation range, and you can see it's clearly 2 standard deviations above the normal range. Snow extent is also right at the 20-year average there, at the 1 standard deviation above the 20-year average, rather, as those blue lines are the plus to minus 1 standard deviation. And lastly, here is the snow water equivalent, which is also more than 1 standard deviation above normal. So we're going to hear articles all year probably about how, oh no, Greenland is melting. So let's just cover it. Let's see how melted Greenland is, shall we? So up here, oh my God, how much snow? Only 8.7 inches there. Oh, 12 inches there. Okay, all right. Look at this. Oh my God, 0 inches. Okay, let's go farther inland. How about here? More than 5 meters, more than 5 meters, more than 5 meters. But only 0.3 inches there. Oh my God, case closed. Greenland is melting. It's time to be very frightened, folks. I'm very, very scared. Are you frightened that Greenland is going to melt? Oh no, sea level could rise 7 meters if Greenland melts. I'm very, very scared. Again, leave us a comment. Let us know how frightened you are. Let's take a look at pressure. Oh look, a massive anticyclone with a clockwise rotation taking place over Greenland. Anyway, here's where pressure cells currently are. Powerful low pressure there over central Canada. And we'll advance this into tomorrow. There's where we expect things to be according to the European forecast for pressure at 12 noon daylight time tomorrow. 12 noon Eastern Daylight Time. High pressure overhead. We're expecting clear skies over the mid-Atlantic. Next, looking at the total accumulated precipitation forecast here. This is the GFS forecast from Tropical Tidbits, and we are still seeing a forecast for like 20 inches of rain now in Arkansas and northeastern Texas, and also a bit in extreme eastern Texas. So that's through 12 Universal Time, 12 Zulu Friday. The GFS forecast for rain there. Some extreme precipitation in the forecast. Let's take a look at the current Doppler Radar Map, and you can see strong storms here, Louisiana, Texas, Oklahoma, and Kansas. Hopefully nobody being delivered to Oz. Here's what's going on in the cloud layer. And we've got stagnating systems and massive pressure gradients. So you've got this dry mass of air right here in between these two blobs. Of moist air. Did I just draw something vulgar? I'm terribly sorry, folks. Anyway, again, there's the cloud layer. Here's the Doppler radar. And when the Doppler radar is not giving you sufficient information, folks, check out the NASA GOES Interactive Weather Satellite Suite. The water vapor map does not allow water vapor to hide. So we're going to zoom in on this area here at the Louisiana-Texas border to just get you a little bit more zoomed in on this couple of atmospheric ponds that have formed over the U.S. It's a couple of atmospheric ponds, and they're taking their time to move because the jet stream is nowhere near there. So a great view of those two systems there. Again, there's the cloud layer, there's the water vapor, and they're just stagnating as that dry mass of air is just hanging out. And that is why there is so much moisture. And one more time, there's the Doppler. There is the cloud layer. And there is the water vapor map. And that's today's meteorology and climate section. I've been your host, Dan, a.k.a. smAsho, and we'll see you later, Twitch.